All right, so let's look at counting and probability objectives. So the first one says to use the fundamental counting principle to solve counting problems. So for instance, question 4 from the test had a restaurant offering salads with three types of lettuce, and then 6 different toppings. And then it had 2 dressings. Okay. And so the lettuce types, okay, so we had 3 types of lettuce. And then you can imagine 6, 1, 2, 3, 4, 5, 6 toppings on each of these. Can you picture that? And then 2 dressings on each of those. And the idea is how many different salads could be ordered. So you had 3 types of lettuce, 6 different toppings, 2 different dressings. At the end of all these branches, we would have a total of 18 times 2 or 36 possibilities. Okay. Another one that was kind of a counting problem situation was that license plate problem. So that was number 5 on the test, where you had 3 letters. So these were letters followed by 2 digits. Okay. So that was going to be the license plates. And it reminded you there are 26 letters, and then you can use the digits 0 through 9. So there's 10 digits. And it says determine the number of different license plates possible if. Okay. And on A, the situation was repetition not permitted on either. On either letters or digits. Okay, so if we did a tree, then we can imagine that off the first branch, we'd have 26 possibilities. But then on the second branch, for the second letter, we've already used one and we can't repeat. So there'd be 25 and so on. So we don't draw the tree, of course. We couldn't possibly. Too many branches, too many possibilities, but we think it. Okay, not permitted. So 26 for the first letter, you have 26 options. But then after that, you only have 25 options. Then you have 24 options. Now we're starting on the digits. You have 0 through 9, so that's 10 possibilities. Repetition's not permitted, though. So after that, there'd be 9 possibilities. And then you multiply that out. It turns out to be kind of big. You get 1,000,000 possibilities. 1,404,000. Okay, that was A. All right, B on the test said repetition of letters permitted. Repetition of letters is okay. With letters, but it said not numbers. Okay, so then you kind of had the same setup, 3 letters followed by 2 numbers. Repetition okay with letters, but not with numbers. So you could have 26 here, and you could choose any one of those 26 for each of the other 2. But with the numbers, it would have to be 10 followed by 9. And then when you multiply all that together, you wind up with this many. Okay. Possibilities. All right, and then the last one I gave you is that the first letter has to be a G or an E. Okay. The first digit can't be, this one has to be G or E, G or E. And then for the digits, the first one can't be 0. So this first one is not a 0. And repetition of letters and numbers is not permitted. Repetition of either. Repetition is not permitted. I'll just say this, no repetition for letters or numbers, okay? So you only have 2 possibilities. Like if you did your tree diagram, you'd have either G or E, but then after that, you could have a lot more branches, but you've already used up 1 letter. You have 2 there. You've already used up 1 letter. Repetition's not allowed. So you'd only have 25 to choose from here, and then 24 after that. Okay, now you can't use a 0, so that would mean you only have 9 possibilities for the first letter. And then whatever that first letter is, you can't use that. I mean, first number is, you can't use that when you pick your next number. So you'd have still 9 possibilities because there's actually 10 digits. You're just not using one of them. Okay. So that is no repetition. I know it looks weird, but that is no repetition of letters. And then that would turn out to be 97,200. Okay, so those are a couple examples of some problems that would fit using the fundamental counting principle to solve counting problems. All right, and then you also need to know about permutations versus combinations. So that was one of the big points we were making on that. Permutations versus combinations. Okay, so for instance, question number 11 on the test versus question number 12. How many ways can a committee of 5 be selected from a club with 12 members? Committee of 5 from a club with 12 members. Oh, I don't want to put which one's which because it's actually the other way around. So let me switch this so it matches so you don't get confused. So you have to understand the difference between permutations and combinations. Committee of 5 from a club with 12 members. And then question number 12 was 10 horses in a race, different ways of getting first, second, and third place if 10 horses were in the race. Okay. So in other words, how could they finish? You know, all the different ways that they could finish. So when you're thinking about that, this is the permutation one. Okay. Because you got those 10 horses, think of A, B, C, D, all the way down. So if A, B, and C is the way they finish, that's actually a different way of finishing than B, A, C. So if you ever see first, second, third, gold, silver, bronze, president, vice president, treasurer, those are permutations. Okay. So this would be the permutation situation. So you have 10 possible horses and you're looking for the top 3 finishers. So you do 10 and then with use the button that has the P on it, and that winds up being 720. All right, over here, this is a combination situation. Okay, because you're just grabbing a committee of 5 people out of these 12 people. That's 12C5. There, like if your committee had 5 people in it, this committee is the same as that committee because it's the same 5 letters. So it's the same committee. It's not a different committee. That's when you use the combination button. And in this case, you would wind up with 792. So they have one problem with permutations. They have one problem with combinations. So you can expect to have to understand the difference between those two. Okay.